Hello and welcome to Würth Knowing. Today we have Jacob here. Jacob is a quality expert at Würth. So Jacob, let's jump into this. Why is quality assurance so important?
I would say it has a big factor on safety and the confidence that our customers have in the parts that we're supplying them.
Sure. I mean, obviously safety is such an important aspect. What happens if we don't really focus on that piece of quality assurance?
I would say it can lead to some major issues. We've had instances where a fitting failed on the brake system of a semi-trailer.
Whoa. I'm assuming there was a big accident.
Luckily, no accidents. It was caught early in the manufacturing line.
Phew.
But it ended up being could have been significantly worse if it hadn't been caught.
Yeah, I could just think about the ramifications if it hadn't been caught. Wow. Okay, so safety, huge. How do we make sure that we have quality products that align with that safety factor?
All right, there's kind of three areas that we look at. There's the compliance side, which is really just making sure we're meeting the ethics requirements of our suppliers, making sure that we're really encouraging good ethical supply sources and product to our customers. There's also the supplier quality side. That's making sure they're following the processes so that we get nice, consistent parts that perform as they should every time. And then there's product quality. That is the part physically working as it should and meeting all the requirements so that it remains safe in the long term for the customer.
All right, so Jacob, this sounds actually really complicated. So where would you even start in assuring the quality of a fastener?
All right, we'd first go with some dimensional measurements. We'd look at the threads and then the plating. I think this might be easier to show you with some of the equipment in our lab.
Okay, sure.
Would you like to go on a field trip?
I'd love to go on a field trip. Yep, let's go. Let's do it.
Let's go to our lab in Brooklyn Park, Minnesota.
From Florida to Minnesota, here we are in Brooklyn Park. I'm so excited to be here. I hope you are as well. Jacob.
Welcome to the Brooklyn Park Quality Lab. I'm very excited to show you, some of the things that we use to measure and determine the quality of the parts that we receive.
Yeah, amazing. I'm so excited. The first thing I'm noticing is this device. Now, this looks familiar to me. Just was at a bike repair shop recently and saw something like this. What is it, and what does it have to do with quality?
This is a bolt reference gauge. It's a wonderful tool that allows us to measure a few critical dimensions on a fastener quickly, simply, and at a very affordable cost. Here, let me show you how to use it.
Ooh.
All right, so if we take a look at the top and bottom here, there's rulers. Since this part is an inch part, we'll use kind of the bottom half of the card.
Okay.
So what we're gonna do is we're gonna catch the bottom of the head on this corner here.
Okay.
And then if we take a look here, you can see how long the fastener is, which is about 2 3/4 of an inch.
Okay, I see that.
All right.
Sorry.
So up next, we're gonna take a look here at the diameter of the screw. So you kind of start at the bottom and just kind of work your way up till you find a hole that fits nice and tightly in.
Okay. Okay, the 5/16 is too small, so maybe, no, that's too big. Oh, 3/8.
Yep.
Nailed it.
So if we take a look, we know now the diameter of the fastener. The next thing you need to know about a fastener is the thread pitch on it. So if we come over here, there's a chart. We find 3/8. It says 16 threads per inch or 24 threads per inch. So if we go to the back side of the card here, you'll look here.
Ooh.
There's kind of these teeth sections. We'll find 16 here, and you just look, and it locks in nice and tight there.
It does.
So that basically tells us we know it's 16 threads per inch. So if we're trying to find a mating part or the gauge to really know the true tight tolerance and stuff, we can go, okay, it's a 3/16 fastener.
It's like a cheat code.
Do you want to see a real cheat code here?
Oh boy, do I.
All right, if we go over here to the caliper, instead of it being good to about an eighth or a 16th of an inch, this is good to the thousandths.
Ooh.
of an inch. So if we go here, it shows us at 2.725 inch. So significantly more accurate. So now that we know the dimension here, to know if it's in tolerance or not, we need to have a customer standard or a customer print. Let me go grab one for us.
All right.
All right, so here we have a standard that kind of shows a bit about it. So first, we'll see a kind of drawing of the part, and then it shows the head marking followed by 4 sections. First talking about thread dimensions, the other physical dimensions, then physical requirement or strength of the part, and then finally it'll talk a little bit about the finish.
Okay, there's a lot of stuff on here. Can we break it down?
Yeah, let's start with measuring threads.
Okay.
So we know this is a 3/16. So I have some thread gauges here. So if you take this part and try thread it through these gauges.
I can't get it through this one.
So if we look at that one, it's a no-go gauge. So basically, if it went through that, it would actually be a bad part.
Oh.
So if we go over to the other gauge here, right, and try drive it or run it through that one.
Yeah, smooth.
Yep. So now that we know it passes the go gauge and doesn't pass the no-go gauge, we know the threads are in the acceptable tolerance range.
Oh.
So this is a nice quick way to measure the parts. There's other ways to do it that are a lot more in depth, take a little bit more skill, but these are really quick and easy ways to measure the threads accurately.
Awesome. Okay, so what's the dimensional data?
Okay, so we earlier measured the underhead length. So if we go through here, there's a few other things it calls out, such as width across flats. This is the wrench size that you'd use, so very critical information. Another one that you commonly see is basically the thread length.
Okay, see
That's basically, telling us, how far can it thread into something.
Okay.
So those are very common dimensions that we're checking to make sure that the fastener, is meeting the requirements.
Interesting. All right, so that's dimensional data. I'm also seeing on each of these letters and lines on the top. Does that have anything to do with anything?
All right, so the lines on the top of that here are basically telling us the strength of the fastener. So the 6 lines here reference it being grade 8.
Okay.
Grade 8 is basically telling us how strong the part is. There's a couple ways that we can measure it that are called out there, such as pulling tensile on it, but one of the quick ways to do it is using the hardness checker. It allows us to, get an analogous reading to the strength.
Hardness checker. Is that the physical requirements then?
Yes, that's the physical requirement that we can measure.
Okay, and how do we do that?
Let's go over to the hardness checker.
Okay, let's go.
All right, so what we're gonna do now is a hardness test. So we're gonna put the fastener on the anvil up here, and what's gonna happen is this diamond indenter is gonna be driven down with 100 kilograms of force, and based on how far in it drives into the fastener, it gives us how hard the part is.
Wow.
So in this case, we got an HRC of 34, which is in the acceptable range of 33 to 39 for a grade 8 fastener.
Okay, so why do we need to know this?
It tells us how strong the part is. You can also pull tensile on the part, which is basically pulling the bolt till it breaks, but that takes more time and is a destructive test.
Okay.
Another thing that we will look at is the head mark. So this will be letters or a shape. That is a manufacturer's maker mark on the part.
Yep.
In this case, I recognize the brand. They are on our approved supplier list.
Okay.
This is where we have a group of auditors globally go out to our suppliers and take samples of parts and check the microstructure and make sure that they can provide parts to the quality that we need, so we have confidence in them to produce these parts for our customers.
Wow. Is that everything having to do with the physical properties? Because I'm noticing there's like a shiny, kind of pretty appearance of this.
Yes, this is an electroplated part.
Plated? Like jewelry? Because that gets my attention.
Yes, same process. So we have a XRF machine which measures the plating thickness on this. Let's go take a look.
All right.
All right, so this is our XRF machine. What we're gonna do now is we're gonna load the part in. And what this machine does is it bombards the part with X-rays, and based off the signal it receives back, it will give us the plating thickness and the material makeup. So in this case, it's a zinc part, so there's a lot of different metals you can plate onto the parts. As we talked earlier with jewelry, it could be silver, gold, etc.
Yeah.
But what we're gonna do is we're just gonna hit go here. It's gonna run for 10 seconds. and then it'll give us a reading on thickness.
Okay. So why would a plating thickness on a fastener matter?
So what it comes down to is the thicker the plating, the longer it stands up to kind of environmental like salt, water, etc. before the base metal starts to corrode and weaken the fastener.
Okay.
So the plating is a sacrificial layer, basically.
Okay. To protect the metal underneath it.
Correct.
Oh, okay. And then why would there be different grades of plating?
There's multiple different standards based on how the part is used, the condition that it's going to be used in, and that'll affect the plating that you choose. So as we look here, now that we have a reading of 8.7 microns.
Okay.
And this had a minimum requirement of 3.
Wow. Okay, so that's like extra plated.
Yep. Yeah. A little extra is better than not enough here.
Agreed. Wow, that was a lot. Like, such cool stuff. I had absolutely no idea that so much went into ensuring the quality of our fasteners. Jacob, that was amazing.
Yes, there's a lot that we check. There's a ton of attributes, but those give us the confidence on the parts that we're sending out.
I'm so excited to have been here and seen all of this. I hope you all enjoyed it as well. Thank you so much, Jacob.
Thank you for coming to visit.
Yeah, of course. And thank you all for coming along on our field trip. We'll see you next time. Bye for now.
It will basically give us the allowable range that a fastener can be in.
You're looking at that camera. Did you look at that camera again?
Yeah, right at the end.
Who did I look over there?
No, I did. I see people, so I look towards people, not towards camera. Yeah.